All right, welcome to practice exam 3. What we'll do is we'll be going to work on looking at the first 10 problems on practice exam unit 3. So let's start with problem 1. Consider the typical 30-year fixed rate mortgage. During which of the following years is the highest portion of each payment applied towards the interest? Now, if you remember about amortization of loans, you'll remember that in order for the bank to make more money, they're going to want more of that interest collected up front, just in case you move after 2 or 3 years. So the very first year is when you'll have the most amount. Okay, the 30th year you actually have the least amount. The 25th and the 15th year progressively less. So you start with most interest on the first year, and then you slowly put less and less and less till you have almost nothing on the 30th year paid towards interest. Calculate the monthly payments for a mortgage of $180,000, fixed rate of 4.5 for 30 years. Okay, so we need to look for the payments. So if you remember, we're going to use our payment formula. If you remember, the payment is equal to the principal times the APR divided by the number of payments. In this case, it would be 12, all over 1 minus 1, I forgot the parentheses here, but 1 plus APR over n raised to the negative ny. So now that we have that, that's what we need to find each of those values. We're looking for payment, so we need to have all the other values. Well, we know the principal will be 180,000, so we can just mark that down. We know that our APR will be 4.5%. We know that the number of periods per year is 12, and the number of years is 30. So with this information, we can now plug into our equation. 180,000 times 0.045 divided by 12, all over 1 minus 1 plus 0.045 divided by 12, raised to the value of negative 360. Now remember, that right there is 12 times 30. So now I can actually kind of go over here and do all this calculation. So we'll come over to our calculator, and we will say 0.045. So 0.045 divided by 12, add a 1 to that, raise it to the power of negative 360, so we do 360 negative. So that value is going to be 1 subtract this. So I'm going to now go minus 1 and take the opposite. So that's another way you could do it, but 1 minus the other value. I'm going to store that in my memory. Oops, I forgot to do that. Made a mistake. We'll just real quickly do that again. So 0.045 divided by 12, add 1, raise it to the power of a 360 negative, and then I'm going to go 1 minus this, so I can actually also do that minus 1 and then take the opposite, and store that into my memory. There we go. So now we'll do memory recall. Yep, we got that in. So now we're going to do the top portion, and that's 0.045 divided by 12. We do the parentheses first. Then we multiply that by 180,000. And we're going to divide this number by our memory recall to give us 912.03 if we round it. So there we go. A right there is my correct answer for looking at that. So now let's continue moving on. Question 3. The following table shows the expense of the payments for the 3 months on a credit card account with the initial balance of $500. So we're starting with $500, and then we're going to make payments and expenses and stuff. Use the table below as a guide to help you find the balance at the end of 3 months. Assume the interest rate is 1% per month, 12% APR. So 12% divided by 12 will give me 1%. The interest for a given month is charged on the balance of the previous month. So let's charge the interest of the first one. So we have 500. We'll clear all this out. So $500 was our balance of the first one. We multiply that by that 1%, and we get $5. So we have $5 of interest. So therefore, if we take our balance, 500, subtract from it our payment of 120, but add on 160 of expenses and $5 for the interest. So now we're at 545. You multiply that by 1%, and I can just say that that's going to be 5.4. So try and get rid of that. Okay, sorry about that. So we're going to do this again real quickly, 5.45. And once again, this was a 5. So now we're going to come down here. 545 was our previous balance. We're going to make a $35 payment, so we subtract $35. And we add $70 of expenses, so we add that in. And we're going to add the interest of $5.45. So our new balance is $485.45. Once again, I guess if I select that, it's going to highlight, so I'm going to just be a little careful with this. So 545 was right here. This one is 585.45. All right, so now we're going to calculate the interest off that one. And so we do that by multiplying by 0.01, which happens to be 585. And so we'll round it up, round it down to near cent. So 585. So we're going to take this balance. Remember, it was 585.45, and we made a $70 payment, so we subtract $70. We have $95 of expenses, so we add 95, and we also add on the interest, which in this case is 5.85, for a total of $616.30. So I look at my final balance, and $616.30, B is the correct answer. All right, number 4. Assuming that a mortgage monthly payment is $760 and the balance of a 30-year loan is currently $135,250. Knowing that the mortgage is financed at 4.5, what do you know about the principal and interest portions of the upcoming month's payment? Okay, so we can look at this. Now we look over here. The interest, so we can say interest, if you will be equal to basically our current balance, which in this case is $135,250. So our current balance multiplied by the APR, which is this case is 0.045, and we're going to divide it by 12 because this is a monthly payment. So that's how much interest we need to pay. So we'll do that calculation real quickly. So I clear this out, 0.045 divided by 12, multiply that by our current balance, which in this case is $135,250. And I added another 0 in there, so that should actually say 507.19. So that's how much interest, and technically that means C is the correct answer. If we want to find the principal, we can just take our payment, which in this case is $760, and subtract that interest, which would give us $252.81. And I know that because there's no other items on here. Okay? And so that's how you calculate the interest for each one. Number 5. Suppose that, so that was number 4. We just finished 4, so now we're on number 5. Suppose you have a balance of $2,500 on your credit card, which charges 18% compounded monthly. If you want to pay off the balance in 30 months, how much should you pay each month instead of the monthly payment? Okay. So what we want to do is we want to look for basically some of the values. So we have our payment is what we're looking for. So we're going to be using that payment formula. So the payment is equal to the principal times the APR divided by n all over 1 minus 1 plus the APR over n, all raised to the negative ny. And the more you do this, the more you just have that formula memorized. So in this case, we know that we have a balance of $2,500. So that's kind of that principal. We know that our rate is 18%, so that's 0.18. We have compounded monthly, so every month, so 12. And then 1 minus 1 plus the APR, which is 0.18 divided by 12, raised to the negative 12 times years. And so this is where we want to pay it off in 30 months. So to calculate that, 30 months divided into 12 is 2.5 years. So I just put a 2.5 up there. And now I can do this calculation. So 12 times that 2.5, and remember that's a negative 2.5 times that. So negative 30 is going to be up there. And just remember that. 1 plus 0.18 divided by 12 gives me that value. Raise that to negative 30. And there we go. And then we subtract a 1 from that. Remember, it's 1 minus that, so I can just take the negative. And that is what I'm going to put in. So memory clear, add that to the memory. Let's just make sure that's correct. Yes. Okay, now we'll do the top, 2,500 times 0.18 divided by 12. And we'll divide that number by our memory recall. So 104.10. So there we go. C is the correct answer on that. All right, so question number 6. Suppose that you apply for a five-year car loan at the amount of $27,000 with APR of 8% compounded monthly. Your monthly payment is $547.46. Determine the total amount of interest you will pay over 5 years. So since we're looking for the amount of interest, what we want to do for this 5 years is we want to take the total amount of our payments minus how much principal we had. So interest will be equal to the payments we make minus the principal. Payments minus the principal, how much we borrowed. Now it'll tell us how much we paid in interest. So to calculate this, first we need to know what the payments were. Well, it says in here that we have a monthly payment of $547.46. So 547.46 cents is our payment. We're going to multiply that by 12 and multiply that by 5. So that's going to tell us, we'll clear out the memory, clear out our calculator, 547.46, multiply that by 12, multiply that by 5. That is how much we paid for our payments, or $32,847.60 is how much we gave them over 5 years. And I'll store that in memory. And now let's figure out how much we have for the principal. That's how much we borrowed for the car, which in this case was $27,000. So I guess I didn't need to do that, but let's do memory recall. Subtract our $27,000, which is how much we borrowed for the car. And so we paid $5,847 in interest, which happens to be D is the closest option. Okay, let's go on. Number 7. You would like to purchase a car and have calculated that the most you can afford to borrow on a vehicle is $100 per month for 5 years with APR 4.5%. You determine that the maximum loan amount therefore should be, so we know our payment, but we don't know how much that we can borrow. So we're going to use the payment formula, but work backwards, where we're looking for P. So in this case, we want our payment to be $100, and we're looking for our P. We don't know that yet. We know our APR is going to be 4.5%, so 0.045, and obviously it's going to be compounded monthly. So all of these values, 1 minus 1 plus 0.045 divided by 12. And we want to do this in 5 years. So minus 12 times 5. All right, so let's go ahead and do this calculation. And I'm going to do the bottom first, then multiply it by 100, because then it would be P times 0.05. So that's kind of just solving for the formula. So we'll do that. Now 12 times 5 is 60, so I'm just going to remember that and go 0.045 divided by 12, add 1, raise it to the power of negative 60, and now I'm going to subtract 1 from that, so remember I can also subtract 1 minus, and so that also is a shortcut. Now I'm going to multiply this by 100. So therefore, I have now 20.1147 ... is equal to the principal times 0.045 divided by 12. Now I can multiply this by the reciprocal, and notice that we'll have these cancel out. So that will cancel out with that will cancel out with that, and then I can multiply the other side by the same thing, so it's multiplied by 12 divided by 0.045. So that's just a strategy on how to do that. So let me just dismiss this. Okay, so now I'm going to come over here. Oops, I shouldn't have erased the 20. Because it might give me different values. So let me just real quickly do that again. 0.045 divided by 12. Add a 1. Raise it to the power of negative 60. Subtract a 1 from that, minus that. Multiply that by 100. Before I forget, let's store that in memory. Okay. Now we're going to multiply this by 12. And divide by 0.045. And so our principal should be $5,363. So we look up here, 5,363, so C is the correct answer, and we're ready to move on. So number 8. All right, let me just fix this a little bit. Here we go. All right, so we're checking out the refinancing possibilities of a home loan. Oops, sorry about that. So we're looking at the refinancing of a home loan. The principal balance is $200,000, and we're going to basically discuss the pros and cons of a 30-year mortgage at 3.25 compounded monthly versus a 15-year mortgage. Okay, we want to find the total difference of interest between those two. So we want to calculate the interest of the first one. Now, what we'll need to do first is find the payment. Okay, and then once we have the payment, then we can look at figuring out how much we're paying total minus the principal to tell us how much we paid in interest. So I'm going to have to do a little bit more work on this one, but it should work out pretty fast. So I'm just going to go straight to the payments. So the payment of the 30, we'll start with the 30, and then I'll do the 15 with the same thing. So 30-year, our payments will be equal to the principal, in this case $200,000. Now for the 30-year loan, we have 3.25. And then we'll just divide that all by 1 minus 1 plus 0.0325 divided by 12. And you can see why we want you to do so many of these. It's because the more you do it, the more you it just becomes second nature to you. Minus 12 times, and this is 30 years, so we'll put a 30 up there. All right, so let's figure out that payment real quickly. So I clear this out, clear the memory as well. 0.0325 divided by 12 gives me that value, and we'll multiply that, add that, I apologize. Add that to 1, raise it to the power of negative 360, and we'll then do 1 minus that number, which in this case gives us 0.62. So I'm now actually going to clear my memory and then store that in the memory. And then let's do the top, 0.0325 divided by 12, multiply that by the principal. Now we're going to divide this by our memory recall, which was the denominator, and so that's our payment. Now we can multiply this by 12 months and by 30 years. And so we end up paying $313,348 and 55 cents over the life of the loan, minus our 200, which would give us about 113,348.55. So that's how much interest we paid on the first one. Now we need to calculate how much interest we're going to pay on the second loan. So we're going to do the same thing. We'll do a payment loan, except for we'll change some of the values. We still have the same principal, 200,000, and we'll multiply this by 0.0325. Oh, sorry, we actually changed this. This is 2.85. So 2.85 is our new interest, and we still have 12 monthly payments. This is all over 1 minus 1 plus 0.0285 divided by 12, all raised to the power of negative 12 times 15. And just as a reference, 12 times 15 is 180. So I'm going to clear out the memory. 0.0285 divided by 12, add 1, raise it to the power of negative 180, and then 1 minus that value will give us 3.47, so we store that in our memory. Now we calculate 0.0285 divided by 12, multiply that by 200,000, and we get 475, divide that by our denominator, and that's how much we are going to be, our monthly payments will be. So we pay $1,300. Now notice our monthly payments are a lot higher, but we're only doing it for 15 years. So 12 months, 15 years. I will pay $246,020.53. Subtract that 200,000, and we will get $46,020.53 in interest. Now, notice that we're looking for is the difference of the total amounts, so we go 113,348.55 minus 46,020.53. And so we're going to be, notice about $67,000 difference, 328. Now, B looks the closest, so that's our answer. And we're ready to move on to question 9. Okay, given that the probability of event E is 0.25, what must be true about event E? So A, the event E is unlikely. That actually makes sense because a quarter of the time it's unlikely. If it was very probable, so notice event E is impossible. No, that's not the case. 0 would be impossible then. The event E is sure to happen. Well, that would be high. You need like 0.8 or higher. The event E is probable but not sure to happen. That would be around 0.6, 7. So obviously A is the correct answer in this case. A restaurant offers pizza with 3 types of crust, 5 different toppings, and 4 different sizes. How many different single topping pizzas can be ordered? Okay. Well, let's see. We have 3 types of crust, 5 different toppings, and 4 different sizes. So you can just law of multiplication across the counting principle, if you will. 3 times 5 times 4, which would give me 15 times 4, which is 60. So 60 is the correct answer, and we are done with part 1. So go ahead, head on to the other parts, and I'll answer further questions as we go through this. Thanks.